Now that we have a clear idea of how the destruction will take place, I will start scattering some points to create Voronoi fractures, or in this case I will use the RBD material fracture node to generate some nice detail to the pieces. So first of all, I will lay down a VDB from polygons node. So I will convert the entire building to a density volume. So remember, the density volume can be used to scatter points inside the geometry. For now, I will use the default resolution, and let's lay down the scatter node. Now, here's an important note. Usually when I'm doing destruction, I would turn off the relax iterations option just to make the distribution of the points more uneven. In this case, I will keep it on. The first pass of Voronoi cells that I want is just a generic breakup of the building, so very regular and big chunks that later I will break down into smaller pieces. So let's see what we get with this setting. I will lay down an RBD material fracture node. I will connect my building to the first input, the points to the fourth input, and let's click on the RBD material fracture node. So one of the first things we want to do is turn off the fracture level 2. So I will click on this tab and then click on the remove icon. And another thing I want to do is turn off the scatter points altogether, because remember, we will be using our own scattered points. So I need to click on the input points to be able to use this fourth input. Now, just an advice here, depending on the amount of pieces that you will be generating and the hardware you're using, these complex fractures may take a while to calculate. So at some point you may want to turn on the manual update, and after creating your setup, just clicking on the update button here to the left to see the results. So for now I will turn the auto update on, but maybe later on I will need to turn on the manual update just to be able to work faster. Another very important thing to consider is that at the end of the process, I will add some detail not only to the edges, but also to the interior pieces. So I usually try to set this up first before starting to generate a great amount of pieces. Then I would turn this additional detail off just before I start simulating. So let's see how this looks. I will add an exploded view, connect it to my RBD material fracture node. And let's go back to the node and look for the detail options. So I know I won't be using a very small size. I'll probably increase it to 0.15. Also for now, just to make it faster. Turn on the edge detail. And as I mentioned earlier, this process will start to take more time. So in this case, it took a few seconds to generate this interior detail, but the more pieces we have and the smaller the detail size we have, the longer it will take. So let's try to nail the detail before we start creating more pieces. And then we can come back and turn it on when we're ready to simulate or to render. So in this case, I want a little bit more jagged edges. So I will increase the noise height, probably to 0.3. And this looks much better. So I think I'll go with this. I have a nice interior detail as well. So for now, let's turn off the edge detail. And I may also want a little bit more scattered points. So Let's take a look at the overall size of the pieces. Again, this is just the first pass, so we have breaking all across the board. And after this, we would typically use constraint and additional fracturing to control where we want the building to break and where we want the smaller details to show. So let's increase the number of points. So now I will turn on the manual update, change the number of points to 2000. And for now, I will turn off the exploded view. I will click on my scattered points and go back to my auto update to have a faster feedback. So remember our plan, we wanted to create some fractures just between the columns of the lower stories. So I will go into the front view by pressing spacebar 3. I will also template my building. And I will create a plane or a grid object where I will be able to scatter a few more points. So I will change the size of the grid to say 30 by 30 meters. I may have to transform it and move it up a bit. So press enter on your perspective just to be able to manipulate it. And I'll make sure to put it exactly on the center of this column. And then I will apply an extrude, in this case a poly extrude node, just to give it some thickness. So let's try with a distance of 1 meter. Make sure that output back and back group are on, because I want to extrude again. So I will add another poly extrude. In this case, I will only extrude the back face. And what I will do is copy the amount of extrusion from the first node and paste it as a reference, so I can also control the inferior extrusion, just so we have a symmetrical box. So this is looking good. I'm going to multiply this box a few more times. I will use a copy and transform node just to copy it a few more times, maybe twice, one for the second story and one for the third story. So the total number of copies will be 3, and I will manually increase the height just about there. Now that we have our boxes in position, I will again convert this into a VDB. So press Shift and drag the lower node to be able to move the nodes from above. And I will press Tab and look for the VDB, convert from polygons. Again, make sure it's a density fog. And one thing I'm going to do before I scatter my points is combine this VDB with the previous VDB we made. I will intersect them together so we have the new scattered points only where needed. So lay down a combined VDB. connect the first volume into the first input of the VDB combine, and the second volume to the second input. Now, under the VDB combine parameters, make sure that operation is set to activity intersection. To activity intersection. Okay, so this is looking good. I will add another scatter. So this time I will turn off the relax iterations. Remember, this will give us a more irregular distribution of points, which usually looks more natural. And again, I will increase the amount of points to say 4,000. So let's now add a merge node, and let's combine our previous points with this second group of points that we have just generated. And I will connect this merge into the fourth input of my RBD material fracture. So let's see what we have so far. I will zoom out a bit. So notice how here in the center of the columns we have smaller pieces. This will look very interesting when the building starts to crumble. And not only that, it will also allow the building to break much more easily in these areas. So again, let's turn off the exploded view. I will go back to my merged points. And finally, what I want to do is a more finer pass exactly where the walls will break. So I just want a very thin fissure on the breaking point of the walls. So what we can do is to copy this geometry we just created. And I will make it thinner using a peak node. So probably I'll use minus 0.8 meters. Let me compare them. Probably I can go even lower to 0.9. And again, I will convert this into a volume to scatter more points. Now, notice before we do that, how the camera is facing only on the corner of the building. So maybe we do not need to generate this much amount of pieces. Probably we can create a bounding box just to limit where the new points will be. So let's do that now. Let's create a box object. Let's go to the top view. And let's move the box, or actually scale it up, just on the corner of the building. Again, let me template the building. Go to the top view. And notice I will only use the corner of the building. Probably something like this. So let's add a Boolean node and intersect the boxes that we first created with this new box. So remember, by default we have the intersect operation, which is fine in this case. And let's now convert again this object to a VDB. Make sure it's a fog VDB. And again, we will intersect this volume with the very first volume we created. This one. So let's add a VDB combine. Connect the first volume to the first input and the second volume to the second input. And now make sure that the operation again is set to activity intersection. So this is looking good. Let's add our scatter node. And this time we'll go a bit crazy with a number of points. Let's turn off the relax iterations and let's create, let's say 25,000. Okay, so let's merge these new points and take a look at our exploded view. Okay, so that fracturing took a couple of minutes. But if you take a look at the corners, especially here where the columns will break, we have plenty of detail, and I think this is going to work fine. At this point, we may want to save this file, so I will lay down our ROP geometry output, connect it to this first input of the RBD material fracture, and change the name of this node to building fracture V01 for version 1, and make sure to save it in our geo folder. So I will change the name to $OS, which is the name of the node. I will delete the frame number because this will be a single frame, and click on the Save to Disk. Finally, I will lay down a file node. I will turn it blue. And I can load the file directly here, or I can also channel reference the output name of the ROP geometry output into the geometry file of this node. So here we have our saved geometry.